During our last class, we stopped under addition and subtraction. Today, we'll be moving to multiplication and division. But first of all, let's treat multiplication. How do we address the matter of multiplication under modular arithmetics? For example, if I have 5 times 8 to module 7, there are two ways to it. Let's separate them first. 5 mod 7 times 8 mod 7. This can no more be reduced because it's already under the reduced form already, the lowest you can have for that course. Then this, you still have 8 bigger than 7. So reducing this will give me 1 mod 7. So this is making it more simpler. Just 1 times 5 will give me 5. So I'm having the value 5 mod 7. Or the other way around, you can just add your 5 times 8 to mod 7. 5 times 8 will give me 40. So we have 40 mod 7. Then now let's reduce 40 to the lowest form. How many 7 can we see in 40? Definitely I'll be seeing just 5, which is 35. Now 35, take away 35 from 40, I'll be left with 5. So I'll be having 5 mod 7. So checking the answers, 5 mod 7, 5 mod 7. That simplify or that justify that the two methods are right. Or let's check another example to justify that the two methods are right. Let's take another one here. Maybe you can try to work with another modulo. But from the text I have with me, I'm taking this one which is with the same modulo. Let's test 2 times 23 here to mod 7. Now, just the same way we did the first one. This will give me 2 mod 7 times 23 mod 7. Now, I can no more reduce 2 mod 7 because it's already in the simplest form. Now, I can reduce this. How many of 7 can I say in 23? That's 3. That's 21, which is 3 times 7, 21. Take away 21 from 23. I'll be left with 2, giving me 2 mod 7. Remember, I told you that under our modular arithmetics, we deal with the remainder as the integer for our values. So which means I can now go further by multiplying the integers. 2 times 2, 4. 4 mod 7 will be our answer. Let's check the other method. If I have 2 times 23 to mod 7. So I have 2 times 23, which will give me 46 mod 7. Now, how many of 7 can I get in 46? Wow, 7 times 6 will give me 42. Now, take away 42 from 46. I'll be left with 4. So I have 4 mod 7. So which justify that as I still have the same answer using 2 different methods. So that means I have the 2 methods justifying my approach of doing multiplication modular arithmetics. For further, should I say exercise for you to solve, to approve yourself of this, I would like to put that to the end of the class. So with this now, maybe I can just go further to just one more example to enhance your understanding. Let's go with 6 times 30 to mod 7. Pardon me for waiting on mod 7, but whatever you are doing using the idea or the method is just applying the same method to any other modulo, meaning it can be mod 6, mod 5, mod 3, or whatever. Just applying the same method. Or better still, let me change this to mod 4. If this is mod 4, how do we address it? I can separate them as 6 mod 4 times 30 mod 4. Now 6 mod 4 can be reduced to 2 mod 4. as our remainder is paramount to us. Then 30 to mod 4 can be reduced to 2 mod 4. From this, 2 times 2, I have 4 mod 4. Remember, it's just like addressing your number base. On that number base, there is no integer or no digits should be equal or bigger than the base. Similarly, there is no integer that should be equal with the modulo, meaning 4 mod 4 is wrong. Now, 4 divided by 4, 1. Remember what? 0, which means my final answer is 0 mod 4. Now, using the other way, the other method, 6 times 30 to mod 4. 6 times 30, 6 times 0, 0, 6 times 3, we have 18 to mod 4. So, how many 4 can I see in 18? That will be 4, remainder 2. How many 2 can I see in 20? That will be 5, remainder 0. So, remember, our integer is our remainder. So, my remainder is what? 0 mod 4. That justifies that whatever modulo I'm working on, I can still use any of these two methods to get to my right answer. All right, let's postpone the exercise or the question to solve to the end of the class today. Quickly, let me move on to division under modular arithmetic. So pardon me, I will have to rub this off. So I have division now, division and modular arithmetics. So moving to examples on that. Here I have some questions like 7 divided by 2 to mod 5. To mod 5. 7 divided by 2 to mod 5. Okay? Before I solve that, let me quickly rub this off. We are through with this. Okay, remember the two methods we used here. We can reduce to the lowest form before adding on, or we can solve directly. But in this case, it's going to be different. Firstly, can 7 be divisible by 2 without any remainder? No. That means in this case, we cannot do that. Though, writing in our modular arithmetics, we deal with the remainder. But here under a particular module divided by the next one, you cannot just put the remainder. That is not right. That is to say, it is not right to say 7 divided by 2 to mod 5 is 1 mod 5. Meaning, you just put 7 divided by 2. Now, that is 3, remainder 1 to mod 5. That's very wrong. That's not the right approach. So what do we do? Okay, let's go back. Recall that when you are writing a particular modulo, for instance, 2 mod 5, 2 mod 5 can represent any other value of mod 5, such as 7 mod 5 to the simplest form is 2 mod 5. 12 mod 5 to the simplest form is 2 mod 5, meaning any other value such that is going to be the addition of 2 to add it up to a multiple of 5. We always give me 2 mod 5. So in this case now, let's quickly reduce both. That will be 7 mod 5 divided by 2 mod 5. This will give me 2 mod 5 reduced to the lowest form divided by 2 mod 5. All right. Now here, I would like to put in the next approach, meaning the next step of method. This is a given mod 5, which you cannot be so precise. I mean, 7 mod 5 also has the same value of what? 2 mod 5. Imagine this is something like 37 mod 5. The same 7 mod 5 can be 37 mod 5. And this 2 mod 5 happens to be just 12 mod 5. So which means if I'm having 2 mod 5 divided by 2 mod 5, it can be any of the values. So I am going to expect a particular answer. Let the answer be x. Let x be the expected answer. So therefore, I can say that my 2 mod 5 divided by 2 mod 5 equals to x. So I can now say 2 divided by 2 mod 5 equals x. So moving one of these two to the other side, it is dividing, and when you get to the other side, become what? You go and multiply. So we have 2 mod 5 equals to the other two coming here to multiply x, giving me 2 times x, 2x. That is to say, 2x equals to 2 mod 5. So now I can divide both sides by the coefficients of x, which is 2. Now, 2x divided by 2 equals to 2 over 2 to mod 5. So, 2 cancel 2, we have x. 2 divided by 2, we have 1 mod 5. Oh, which means it will have been possible here, 2 divided by 2, when they can divide each other directly. Okay? Let's take another example and justify that. I have another one here. 14 divided by 3 to mod 9. To mod 9. Alright? Which means 14 is not directly divisible by 3. So I can still take this approach. So better still, I have to reduce this 14 mod 9. If 14 mod 9 is reduced to the simplest form, that will give me 5 mod 9 divided by 3. Oh, sorry. To make it more clear, that's 14 mod 9 divided by 3 mod 9. So 14 can further be reduced to 5 mod 9 divided by 3 mod 9. Now from this place, I can say my x equals to 5 divided by 3 mod 9. So my 3, which is dividing 5, will come to the other side here, giving me 3x. The 3 will come here to multiply x, meaning it's coming to multiply x, multiply both sides by 3. So I'll be left with what? 5 to what? Mod 9. So I have 3 times x. The x is there, the 3 is being swapped to the other side for multiplication. So I have 3x equals to 5 mod 9. So now I need a multiple of 9 to be added to 5 so that I can have a value divisible by 3. What are the multiples of 9 I may need? Okay, multiples of 9 are 9, 9 plus 5 giving me 14, which cannot be divisible by 3. So another multiple of 9 is 18. 18 plus 5 will give me 24. Wow. 23 there, which is not divisible by 3. Another multiple of 9 with 18 there, that will be 27. 27 plus 5 will give me 32, which is not divisible by 3. Okay. Next multiple of 7 there will be 36. 36 plus 5, that will give me 41, not divisible by 3. Another multiple there, the next multiple there will be 45. 45 plus 5 will be 50, not divisible by 3. The next multiple there will be 54. 54 plus 5 will be 59. Is that divisible by 3? No. What's the next multiple there? That will be 63. 63 plus 5 will be 68. Will 68 be divisible by 3? Let's see. 6. Sorry, that will be 68. 6 to 3, not divisible. The next one will be 72. 72 plus 5 will give me 77. Oh, will 77 be divisible by 3? Let's check. 77, 3 here to remainder 1. 17, not possible. So, the next one there will be 81. 81 plus 5 will not be divisible by 3. Wow. Which means we still have a long way to go. Now, after that, I will have 1 plus 9 give me 90. 90 plus 5 not divisible by 3. So I have 99. 99 plus 5 not divisible by 3. Oh, what is the cause of this? Every mode 9 is a perfect value so that 3 is a divisor of any mode 9. Any mode 9, 3 is a divisor of that mode 9. So definitely, if 3 we divide every value of mode 9, and we have a remainder of what? 5, which is not divisible by 3, definitely we cannot get a what? A value of mode 9, 5 mode 9 that what? Can be divisible by 3. So at what there? We can have x equals to 5 over 3 to mode 9, which we don't have in normal case have 5 over 3, such a fractional form of mode 9. We usually don't have a fractional form of mode 9. So which means at the lowest form there, this is the possible value we can get. Now moving on to another example. Let's check where we have 10, that's be my example 3, divided by 5 to mode 6. In this case, this is very exceptional and so quick. These two numbers can divide themselves straight away without any remainder. So 10 divided by 2 will give me, 10 divided by 5 will give me 2. So I have 2 mode 6. Is that possible? Is that allowed, or is it going to give us the expected answer? Let's check. If I have 10 divided by 5 to mode 6 equals to x, such that my 5 is moving to x, giving me 5x equals to 10 mode 6. Now let's divide both sides by 5. I have x here equals to 2 mode 6. Oh, that justifies my answer. 2 mode 6, 2 mode 6. All right. One more example on this before we move on. If I have example 4, 18 divided by 7, 2 mode 7. This is more, or let's say 18 cannot be divisible by 7. So I can say 18 divided by 7 to mode 7 equals to x, such that, 7x, meaning 7 going to the other side to multiply x, equals to 18 mode 7. Will that be possible? How do we expect to get an answer? 7 to divide this to get a mode 7. If this is not divisible by 7 and I'm having 7, definitely we will not get to a particular answer. It will be like this one. Meaning, reducing this one now, 7 in 18, that's 2 of it, 14. You'll be left with 14 minus this, that's 4 mode 7. And I'm having 7x here. Wow. So definitely, if I am going to divide through, I will not have a value because 7 and 7, these are perfect divisors of each other. Then I have a remainder. So every multiple of 7 plus the remainder 4 will definitely not be divisible by 7. So therefore, in this case, x will be 4 over 7. And note, in this form of the expression, there is no definite answer to this 2 mode 7. So except we can leave it at this form. Okay, now I would like to proceed to algebraic expressions in modular arithmetic. Algebraic expressions in modular arithmetic. algebraic expression in modular arithmetic. What do I mean by that? If I have something like 2x plus 1, 2x plus 1 being equals to, let me take something like 5 to mod 6. Let me take this as my example 1. So having this, now we have 2x equals to 5. 1 is moving to the other side, which will give me 5 mod 6 minus 1 mod 6. This is easily possible. 5 minus 1 will give me 4 mod 6. So we're having 2x to 4. Oh, 2 is a perfect divisor of x. So dividing both sides by 2, we have x being equals to 2 mod 6. Meaning I'm applying the idea or the method of subtraction in modular arithmetic and division in modular arithmetics. Okay, another one here, if I have 3x equals to 2 to mod 5, that means I need a mod 5 with remainder 2 that is divisible by 3. A perfect one there is 12. So I've increased. In the other case where we're doing multiplication and division, we were reducing during multiplication of modular arithmetic and addition of modular arithmetic, and also in addition and subtraction of modular arithmetic. There was a place where we had to reduce. But in this case, I have to increase back to a particular value of mod 5, which is 2 mod 5 to increase to a particular value, such that that value is divisible by 3. So 12 mod 5 is the same as 2 mod 5, but 12 is divisible by 3. So in this case, I can now say my 3x divided by 3 equals to my 12 divided by 3 to mod 5. So 3 cancels 3, it's giving me x. 3 in 12 giving me 4. So my value or my answer is 4 mod 5. 4 mod 5. Now to another expression. If I have 2x, oh, we have done something of 2x again. Okay, let's just move on. 2x plus 6 equals 1, and that should be taken to mod 7. Okay, just like we did, this is mod 6, this is mod 5. Let's do this in mod 7. Mod 7. Okay, having this in mod 7, that means I'm going to have 2x equals to 6. Oh, sorry. 6 is going to the other side, so I'll be having 1 minus 6 mod 7. Oh, instead of that, I would prefer to have 1 mod 7 minus 6 mod 7. So from there, my 2x will be a multiple of 7 plus 1, so that the value will be what? Greater than 6. So I prefer to increase this to 8 mod 7 minus 6 mod 7. So 8 minus 6 will give me 2 mod 7. So giving my 2x to be 2 mod 7. So now I can divide both sides by 2, such that x equals 1 mod 7. Which I believe with that, the algebraic expression should be made clear there. I think I still have one more here to give out. If I have 3x plus 4 equals to, 3x plus 1 equals to 4 to mod 7 too. So I'll be having 3x equals to 4 minus 1 mod 7, which will give me 3 mod 7. So my 3x being 3 equals to 3 mod 7. I can have 3x divided by 3 equals to 3 over 3 to mod 7. So 3 cancels 3. I have x. 3 and 3, that's 1. X is 1 mod 7. As you can see, it's a very simple topic to address. Just similar to the concept of your number base. So with this, I believe working or solving modular arithmetic should be more simple. So I'll be giving some exercises now, which should cover what we have learned so far under modular arithmetic. Now, let's take some exercises. You will try 90 divided by 10 to mod 4. Second exercise, we will try 10 times 12 to mod 7. The third one, we will try 14 divided by 5 to mod 7 too. Let's try 4x equals to 6. That should be to mod 5. And the last one, if I have 3 plus 11 to mod, let me make it to mod 8. Thank you. And I hope, I believe, you do enjoy and understand the class.